Assalamualaikum to everyone. Today I will be presenting about the determination of sulfur dioxide in wine using titration. This topic combines food chemistry and analytical technique, especially how we can measure SO2 level in wine using titration method. What is wine? Wine is an alcoholic drink made by fermenting grapes. During the production process, winemakers often add sulfur dioxide or SO2 to preserve the wine. It helps to prevent spoilage, keep the flavor stable, and maintain its color. Without SO2, wine can easily get spoiled or lose its original quality. Okay, next is introduction of titration and SO2 in wine. Titration is a laboratory method used to find out the concentration of a substance in a solution. It involves adding a standard solution called the titrant, drop by drop until a reaction is complete. This point is called the endpoint. In this experiment, we use titration to measure the amount of sulfur dioxide in wine accurately. Okay, next is sulfur dioxide is a colorless gas with a strong sharp smell. It's commonly used as a preservative and antioxidant in many food and beverage industry. In wine, SO2 prevents spoilage and stops the wine from turning brown and changing flavor. However, too much SO2 can be harmful to health, so the amount must be controlled and tested properly. Okay, next, the purpose of this experiment is to determine the concentration of SO2 in a wine sample using titration. It also helps us apply titration in real-world situations, especially in the food and beverage industry. This process allows us to check if the SO2 level is within safe and acceptable limits. Lastly, it gives us a better understanding of the importance of preservative in quality control.
Now let's talk about the basic component used. The first and most obvious component is the wine sample itself, which contains the sulfuric dioxide that we need to analyze. Next, we have sulfuric acid, which provides the acidic environment necessary for the reaction between SO2 and iodine to occur efficiently. Without acidic conditions, the reaction would not proceed properly. And then we use the iodine solution. Iodine is the key reagent in this titration. It reacts directly with the SO2 present in the wine, allowing us to quantify its concentration. We also use a starch indicator. This is a sensitive substance that helps us visually detect the endpoint of the titration. When iodine remains unreacted in the solution, the starch forms a blue-colored complex, making the endpoint easy to observe. After that, we have distilled water, which is essential for rinsing the equipment and diluting solutions to ensure accuracy during the titration. It helps prevent contamination and ensures that only the intended reactions are taking place. For the burette, a precise instrument used to deliver the iodine solution into the wine sample. This allows us to carefully control the amount of iodine added and observe the reaction closely. Finally, we use a beaker which acts as the reaction vessel. It holds the wine sample and other reagent during the titration process, making it easier to stir and observe the changes in color as the reaction occurs. Each of these components play a crucial role in the determination of sulfur dioxide in the wine sample. By using them correctly and following the procedure carefully, we can obtain accurate and reliable results for our analysis. The type of titration used for determination of sulfur dioxide or SO2 in wine is called iodometric titration, and it is a type of redox titration. Redox means there is a transfer of electron between two substances. One substance loses electron and the other gains electrons. In this titration, the SO2 in the wine acts as a reducing agent, which means it loses electron. The iodine solution that we add works as oxidizing agent, meaning it will accept those electrons. So during the titration, we add iodine solution slowly to the wine sample. The SO2 will react with the iodine immediately. This reaction continues until all the SO2 in the wine is gone. But how do we know when the SO2 is finished? That's why we use starch indicator. Starch helps us see the endpoint clearly. As soon as there is no more SO2 left to react, the iodine remains free in the solution, and the starch reacts with the iodine, turning the solution into blue color. When the blue color appears, it means the titration is complete and we stop adding the iodine. After that, we can calculate how much iodine was used, which tells us how much SO2 was present in the wine. So, why do we use iodometric titration? It is a simple, effective, and reliable method to measure SO2 in wine. It helps winemakers control the amount of SO2, which is very important. If the SO2 is too low, the wine can spoil, lose its color, taste, or aroma. If the SO2 is too high, it can affect the safety of the wine. This method also has a clear visual sign that blue color at the endpoint, making it easy to carry out even for people who are not expert.
For this slide, let's talk about why we need to measure sulfur dioxide or SO2 in wine. SO2 is commonly added to wine as a preservative. It helps to protect the wine from oxidation, which can change the color and taste, and also prevent microbial contamination. In wine, SO2 exists in two forms, free SO2 and bound SO2. The free form is the active part that protects the wine and is the one we want to measure. That's why in this experiment, we focus only on determining the amount of free SO2 using a method called iodometric titration. Now, let's look at the chemistry behind the titration method. We use a technique called iodometric titration. It works through a redox reaction, where sulfur dioxide reacts with iodine in an acidic solution. The balanced chemical equation is SO2 plus I2 plus 2H2O yields H2SO4 plus 2Hi. What this means is that 1 mole of SO2 reacts with 1 mole of iodine, producing sulfuric acid and hydrogen iodide. During the titration, as iodine is added, it reacts with the free SO2 present in the wine. Once all the SO2 is used up, extra iodine remains, and that's where we use starch indicator. It turns the solution blue when iodine is in excess. That color changed in our endpoint, and from the volume of iodine used, we can calculate how much free SO2 was present in the wine sample.
For the methodology, we have three parts, which is the first one, iodine solution standardization. The iodine solution concentration is determined weekly for an accurate calculation. This weekly standardization is critical because the exact concentration of iodine is used as a factor in the sulfur dioxide calculation. Next, for the second part, for wine sample preparation, first we need to fill the burette with the iodine solution. And then, we need to measure 10 ml of wine sample using a pipette and place it into a beaker. This precise volume of wine is crucial for an accurate calculation later. And then, we need to use 1 ml of hydrochloric acid and 3 ml of starch indicator solution into the sample. And then lastly, don't forget to add some distilled water into the wine sample. We use hydrochloric acid to help creating an optimal acidic environment for the reaction, and we use the starch indicator because it provides a clear visual for the endpoint of the titration. For the last part of the methodology is the titration process. Firstly, record the initial reading of the iodine solution. Make sure the meniscus is on your eye level. And then, slowly add it drop by drop the iodine solution into the prepared wine sample, as you can see in the video. Next, closely observe the color change. Specifically, the solution will turn dark as the iodine reacts with it. And lastly, the titration is stopped when the entire solution turns dark and the color persists for a short period to indicate the endpoint and all the free sulfur dioxide that has reacted with it. And don't forget to record the final reading of the iodine solution that has been used during the titration.
So, this is the result of titration to determine the SO2 in wine. Next, we move to the calculation to determine the free SO2 in wine. Firstly, we need to multiply the volume and normality, and we multiply it with the 32,000 divided by volume of wine sample. Then we will get the answer, it is 576 mg per liter. This is extremely high because the typical safe levels for wine range between 20 to 50 mg per liter for table wines and up to maybe 100 to 150 mg per liter for some whites. A value that high likely indicates experimental error are either over titration, using wrong concentration of iodine, or forgetting indicator. Because its exact concentration may change over time due to oxidation, light exposure, or incorrect storage. Secondly, watch the endpoint carefully. The endpoint of the titration is detected by a color change due to the interaction between iodine and the indicator. Missing the endpoint or overshooting it can result in either under-titration or over-titration, both of which will affect your titer value and skew your final result. Lastly, buffer volume method. A buffer solution is added to maintain the correct pH during titration. In this case, to ensure the sulfur dioxide remains the correct chemical can perform to react with iodine. In conclusion, the free sulfur dioxide content in a wine sample was successfully determined using an iodometric titration method. Through accurate titration trials, titer volumes were obtained with minimal variation, indicating good precision in technique. The average titer was calculated and used to estimate the concentration of free SO2 present in wine. The presence of SO2 is essential in winemaking as it acts as a preservative, preventing oxidation and microbial spoilage. However, excessive SO2 can affect the taste and safety of the wine. The result obtained in this experiment suggests that the wine sample contains a moderate and acceptable level of free SO2 within typical commercial limits. This experiment also highlights the importance of careful titration, accurate reading of direct volumes, and consistency in technique. Minor experimental errors such as endpoint detection, delay, or inconsistent drop control may slightly affect the result but can be minimized with practice. That's all from us. Thank you for watching. Bye!